Assalamu alaikum dear viewers, welcome back to my YouTube channel. I hope you are doing well. So today we will start question number 4 of exercise 3.1. So question number 4 have two parts. So first part is find the value of m for which the vector A is parallel to vector B. So given that vector A is parallel to vector B and we have to find the value of this small m. So let's start our solution. We write here given that A is parallel to B and the condition for parallel vectors is A is equal to lambda times B vector. So it means we have to take common from any vector. For example, if I put the value of A here 3i plus 4j minus 9k and b vector is I plus mj minus 3k. So for parallel vectors, if we compare the components, so its ith component will be equal to its ith component. Here ith component is 1 but here is 3. So it means we can take 3 common from this to equate the ith component, that is 1 and 1. Similarly, if we take common 3, the kth component is also equal minus 3 and minus 3. So by taking 3 common, I plus 4 by 3j minus 3k is equal to I plus mj minus 3k. So here lambda is 3, this lambda, and this is b vector or this is a vector. And by equating or by comparing the components or corresponding components, we have 1 is equal to 1, minus 3 is equal to minus 3. So it means 4 by 3 is equal to m, which we have to find. So value of m is 4 by 3, which is our required answer. So first of all, you have to keep in mind that we have to equate the components, other components except mth component. The component which involves m is not cannot be equatable, so we can equate the components which do not include m or which are constant components. For example 3, so we have to make 3 here or we have to make 1 here so that they both will be equal. Similarly, the last component will also be equal. So by making these two equal, we come to know that the value of m means third component will also be equal. So value of m is 4 by 3. Now let's start our second part. Find the values of lambda for which the points P, Q and R are collinear. It means P, Q and R points are collinear, means lie on a same line. For example, here is P, here is Q and here is R. Sorry, here is R, so that they will be collinear. So given that this vector and this vector are the position vectors of point P, Q and R respectively. We already know that the position vector is a vector which tells us the distance of that specific point from origin. It means first vector, which is I plus 2j plus 3k, represents this position vector OP. The second one represents OQ, which is minus 2i plus 3j plus 5k. And third vector represents OR, which is lambda I minus k. So we have to find the value of lambda, this lambda, and given that the point p, q and r are collinear. So first of all we have to find the vector pq and qr and pr. So we will find the three vectors and then we compare the parallel vectors and find the value of lambda. So please don't mix these vectors with vector PQ or QR. These are the position vectors and we always compare the vector PQ and QR which are parallel if these points are collinear. So these vectors are not comparable. We have to find PQ, QR and PR firstly and then we compare those vectors. So let's start vector PQ which is equal to Q minus P and Q means OQ or you can write OQ or OP here. So OQ means minus 2i plus 3j plus 5k minus OP which is I plus 2j plus 3k. So after subtraction we get minus 3i plus j plus 2k. Similarly, QR OR minus OQ. Write vector symbol over these vectors since these are also vectors. If we write P or Q only, so these represent the point, but if we write OQ, OP, these represent the vectors, so you have to put the vector symbol over these. So by putting values, OR is lambda I minus k and OQ is minus 2i plus 3j plus 5k. After subtraction, we get lambda plus 2i minus 3j minus 1 minus 5 which is minus 6k. So finally we will find PR which means OR minus OP and OR means lambda I minus k and OP means I plus 2j plus 3k. So the answer is lambda minus 1i minus 2j and minus 1 minus 3 minus 4k. So now if we compare PQ and QR, we come to know that if we take minus 3 common from QR, we get 1 here and 2 here, which will be equal to PQ's components. So it means we have to compare both these since PQ is parallel to QR. So value of PQ is minus 3i plus j plus 2k and here we take common minus 3. So I will write after taking common. So minus 3 common means lambda plus 2 divided by minus 3 I plus j plus 2k. So here j and 2k is equal to j and 2k and we have to compare the ith component, that is this one. So minus 3 is equal to lambda plus 2 divided by minus 3. So minus 3 will be multiplied here. Lambda plus 2 is equal to 9 and lambda is equal to 7. So this is our final answer which we have to find the value of lambda. So value of lambda is 7. Let's start our next question, that is question number 5. Question number 5 also have two parts. So First part is if A vector, B vector and C vector, then find the unit vector in the direction of this. So you are given with A, B and C vectors and you have to find the direction, a vector in the direction of this vector. So let V vector is equal to 2A minus 3B plus C. So by putting values, we get V vector first. So 2 and A is equal to I minus 2J plus K minus 3, and B vector is I minus J minus K plus C vector is 2I plus K. So this is 2I minus 3I plus 2I, which is equal to 1I minus 4J plus 3J. So minus 4I plus 3J is equal to minus J. Here is no J component. So next last component will be 2K plus 3K, 5K plus K, which is equal to 6K. So this is the vector V, and you have to find a unit vector. Unit vector in the direction of V is V hat, which is equal to V vector divided by magnitude of V vector. We already learned this formula in the book. So by putting values, first of all we put the value of V vector, which is I minus J plus 6K, and in the denominator we find the magnitude, and magnitude is simply as simple as distance formula. So first of all, ith component, square of ith component plus square of jth component plus square of kth component and whole square root. So after simplification we get I minus j plus 6k as it is, and 1 plus 1 2, 6 square means 36 plus 2 38, square root 38. So required vector is, this head represents the unit vector, so you will not draw an arrow over here, you have to draw an head which represents unit vector. So I over square root 38 minus j over square root 38 plus 6k over square root 38 is the final answer, final unit vector which is required in this question. So second part of this question is use vectors to find the length of diagonals of a parallelogram having adjacent sides I plus 2 and I minus 2. Adjacent means which are close to each other or which are connected to each other. So here this side and this side are adjacent sides. Similarly, these two sides are adjacent, these two are adjacent, and these two sides are adjacent. So we will draw a parallelogram. Here this adjacent side and this adjacent side are represented by these two vectors, and we have to find the length of diagonals. So first we find the diagonal r1, since you all know that there are two diagonals, so we will find their lengths by one. So first consider the diagonal 1, which is represented by r1 over here. So r1 is the resultant of these two vectors by head to tail rule. So it means if we add these two vectors we will get the answer of r1. So I have added, and answer is 2I minus j. And for length we have to take the magnitude, since you all know that this is a vector number, vector quantity, and length is a scalar quantity. So to make the vector scalar we have to take magnitude, and answer is square root 5. So length of this diagonal is square root 5. And similarly, for the next diagonal r2 we have to consider these two vectors, since you all know that in parallelogram opposite sides are equal and parallel. So if this is I plus j, this must be equal to I plus j. If this is I minus 2j, so this should be I minus 2j. So for r2 we have to add these two vectors by head to tail rule. If this is a resultant vector and direction of this vector is fine, but direction of this vector is not fine. It means the direction of this vector will be this side. So if a vector, one formula you have to remember in your mind is OA is equal to A minus times AO. It simply means if you change the direction of vector according to your formula, so you simply put a minus sign with the changed vector. So we have to change this vector, so minus sign will be put here. So it makes it minus I minus j. So that's why I write a minus sign over here. And after simplification, we get to know that the length of second diagonal is 3. So we can write here, hence the lengths of diagonal of a parallelogram are the lengths of diagonals of a parallelogram are square root 5 and 3 units. Units means meter, centimeter, whatever you want, unit you want to add with these quantities. So I hope you have no confusion till here. I have to end my lecture here. In the next lecture, we will start the next question. Until then, you remember me in your prayers. You keep yourself happy and healthy. And how did you like my video? Please tell me in my comment section. Take very good care of your health. Allah Hafiz.